honestly, like almost every organization that I work with today is facing this exact challenge. 5 years ago, I would say like the main question was how do we improve observability? Right now, the conversation has changed, and I would say, especially in healthcare, in life critical environments, observability is definitely no longer.
Welcome everyone again. Really glad to have you joining us today. My name is Ploy Wongtalatkwan. I am marketing manager at Hyperflex, and today I'll be your guys' host for today. And about today's session, we are diving deep into the challenges that faced across industries. We're going to talk about the healthcare, medtech, criticals, infrastructures, and in this session, we will explore how you can keep these high-stake platform runnings while maintaining your control on those observability causes. All right. But before we get started, let me give a quick bit of a background of who we are at Hyperflex. We were founded by passionate elasticians, and today our team have grown so much that we have a number of certified engineers who live and breathe in this ecosystem every day. Um, Essentially, we provide end-to-end observability and search consulting. Whether you need seamless migration services, managing services, we got you covered. Okay, that's just a little bit about us. Hyperflex, we operate globally out of two main hubs. Our offices in New York, and we also operated from Pune, India. So this allows us to deliver a support whenever and wherever your partner needs it. All right, now we're going to talk about numbers. In numbers, we help clients pocket $75,000 in saving in just 6 months by enhancing their search performance and unifying their observability data. And on top of that, through strategic elastic upgrades, we cut their search latency in half by slashing the total operational costs over around 75%. So those are the numbers. And these are one of our exciting tools that we have is the Splunk to Elastic migration. So if you're currently using Splunk or considering to move to Elastic, this tool is really exciting for you. It features automated fields mapping that convert thousands of fields in just minutes, automatically translates Splunk queries into Elastic queries language, and it migrate your alerts with almost zero manual setups. So with this, we also generate the pre-migration report, so you know your cluster health and feasibility before making any moves. Here's another tool that I really excited to share. So it is the Elastic Seamless Upgrade. So if you work around Elastic, you know that upgrading Elastic is pretty much coming up essentially every 2 months or so. So that's why we created these tools where you can upgrade your Elastic cluster automatically in just one click. So you know that if you work for the very popular industries like finance, healthcare, downtime is simply not an option for you. That's why we created these frameworks. It runs pre-check, snapshots, validates cluster health beforehand, so you don't need to worry about the downtime or make sure that your system is up and running. So this tool allows you to have a one-click upgrades, and all you have to do is wait and enjoy your coffee while system is upgrading. All right, I know what you guys are waiting for. So I would like to introduce our speaker, Savagya Tiwari. He is our senior technical engineer and elastic engineer at Hyperflex. He is a certified observability engineer with incredible track record of designing highly scalable data pipeline for major industries. So we're incredibly lucky to have him today. Savagya, the floor is yours. I'll let you take over the screen.
Good morning, everyone. Thank you for spending the time with me today. I genuinely appreciate everyone joining. I am Sarvagya Tiwari, senior technical consultant right here at Hyperflex. So I'll give a quick background. I've worked around Elastic for a while now. I've handled observability, I've handled security and search use cases for a lot of clients. I've majorly worked on several large scale observability platforms, and I've provided some kind of optimization initiatives across different industries. So, like healthcare, banking, some kind of enterprise infrastructure. So, I'll be sharing some of the work with you all today. I know there are folks who could have more experience than me as well, but there are some examples that can like really help gaining some kind of insights that I've faced in certain examples. So today we'll mainly focus on healthcare. I will use some examples of other industries here and there as well. So before we officially starts, I would like quickly understand the audience a little better. There must be a lot of you who are currently handling a clusters, and like how many of you are currently dealing with maybe rising observability cost, or telemetry volume being exploding and retention challenges. You can like drop it in the chat or raise a hand. We can definitely chat about that. And honestly, like almost every organization that I work with today is facing this exact challenge. And what's interesting is that 5 years ago, I would say like the main question was how do we improve observability? Right now, the conversation has changed, and the main question is how do we scale observability, and that too sustainably. Like this is the key word right here. And I would say, especially in healthcare, in life critical environments, observability is definitely no longer optional. Like itself is becoming expensive, though, of course, but there are organizations now which needs observability strategy more than just the observability tool. I know other than Elastic, there are a lot of tools that is providing observability as well. But we need a strategy that is cost efficient, that is doing our work, that is keeping everything all together, right? So moving on, I will quickly go over the agenda for today. Right now, we will basically be talking about where observability spend becomes inefficient, how ILM like dramatically reduces the cost. We'll be mainly talking about ILMs as well, because that is, I think, one of the major key tool that Elastic is providing that can reduce our cost in the long run. How architecture decisions impact the cost, and of course, why observability as code matters. We will be going over that. We'll be going over some real world examples as well of organizations that I've worked with for reducing cost while like improving reliability. So throughout the session, I'll share some examples of actual environments I worked on. And my goal today is not just to explain the concept, just my goal is to like give you an idea of how you can take back this into your own environment, right? All right, so moving on. Okay, so let's first uh, put it on the table what the challenge is. So we have seen a lot of healthcare environments that are incredibly telemetry heavy, right? Like think about a lot of systems, and all the systems are generating logs. We have each EHR systems, we have APIs. If we are working on Kubernetes, we have Kubernetes. We have different databases, we have different services, cloud infrastructure, medical devices, number of things, right? And all of them are working 24/7. They are operating. They need strict compliance, and I think there is, in most of the cases, there is zero tolerance to downtime because it is life critical. So generally, or that creates an enormous observability pressure. Like I would say, how many of you seen the and like a situation or face the situation where observability storage grows faster than the application itself? We now have a comparative data volume in terms of volume. We have the actual storage as well. We are creating some kind of observability storage that is equal to the like the actual storage. That happens all the time. So that is one thing that we need to take care of, and which we'll be discussing today. Uh, so for healthcare environment that I worked on, they had a massive telemetry growth, and like in my case particularly, nobody was revisiting it. They had retention policies, they had shard sizing, they had mapping, they designed it a while back, and the storage kept scaling, but like the observability quality was not improving at all. So how can that impact our system in the long run? We'll be discussing that. So let's go why the costs are increasing. So as I said, the data is the main reason of why the costs are increasing. Of course, we have the data explosion. We all know we are now working with TBs of data if we have clusters like a large scale environment. So we have structured logs, we have distributed traces, we have matrices, we have events, a lot of stuff, and we are definitely over collecting it because we need it all the time, right? So we need to ask that question whether we need it or not. In many cases, nobody will actually use it after a certain point of time, right? So that is there. Like over time, that create a lot of cluster overhead, unnecessary like memory usage. We get JVM pressure with that as well. We get, of course, it is costing us for the scaling as well, right? So there are certain things that is there to reduce this, but you get the aspect of cost being associated with a large explosion of data. This is very important, right? If we have certain kind of shard strategy in the long run, that can affect our cost. If we have certain kind of ILM retention policies in the long run, that can affect the cost as well. So observability cost is rarely caused by one giant mistake, but usually it is like a thousand small inefficiencies, right? You can have a small inefficiency in the retention policy, which in long term will affect you a lot. All right. So this is where the cost is right now being affected. Another thing is where is our spend being wasted, right? So if I talk about like this is probably my favorite sections because this is where the most of
Hello.
the savings. Sorry. Yeah. Yeah. All right. So this is where most of the saving actually comes from. This is where we can talk about the hidden waste, right? So, for example, I'll be talking about this example in detail later as well. But one of the organization has certain kind of mappings. They were using that for a lot of indices, and that mapping was not optimized. They were using some inline synonyms as well. I'll tell that in detail when will be discussing real impacts, real world examples. So they had the mappings all over the place. So now individually, this seems like a tiny or a small thing. But when we talk about enterprise scale, those decisions can be very expensive, right? So decisions like this, small decisions will affect our cost. This is where the spend is wasted. It could have life cycle, as I mentioned. We could have the storage problem. There are a lot of clusters. Are a lot of indices which are currently storing data in hot and they are not using it for search at all and they are just wasting their money, right? So decisions like this can affect a lot. All right, so let's move on. Right. So now moving on to a gap between the data growth and a cost control. I will say for the introduction, I say this is one of the biggest gap I see. Telemetry data growth is exponential, while governance maturity I think grows very linearly. One example, I was working with an enterprise platform, and they were dynamically like using indexing, and they were using nested fields for thousands of fields, and over time it was not working at all. I think we will be discussing that as well. So just keep in mind like small mapping explosion, massive heap usage, slow queries, or maybe huge index growth. All of this can accumulate and can affect our cost at the very end. All right. All right. Now moving on to our first the major part of the webinar, that is ILMs and how we can improve our costing based on this. I will say this is like the most efficient tool to uh, be cost efficient. I'll be going over this from the beginning because on certain webinars I have actually dealt with, like I have talked about index management, I've talked about indices, shards and everything. But this is the first time we'll be tackling ILM, so I'll be going in depth with this. I have actually created a cluster as well, so I'll be sharing that too. Give me just a second. So moving to that because that will be easier to understand. I hope this screen is visible right now. All right, perfect. So I have created a demo cluster on Elastic for the particularly understanding ILMs, and we will be talking over some other issues as well. So firstly, I'll show you where we can find ILMs and what are ILMs, what do they provide, what are we dealing with. So right here in the cluster, you can see on the very top, this hamburger, we can just click on that. We can scroll at the very bottom. You will find the snack management option there. If we click on that, you will see index lifecycle policies. This is basically our ILMs. I have not created any right now. These are all the default ILMs. So I'll be creating one in front of everybody right now. And let's do a create policy button. Let's just do my first ILM. Okay. Now I'll be going over each of these things in a little detail. What Elastic is offering right now in terms of ILM and what I'm talking about basically. So let's talk about what exactly is ILM first. Basically, if there is one capability that every organization should implement, that is ILMs. It should be proper. So what I mean by ILMs is nobody initially says what happens to this data when it becomes suppose 500 terabytes. What happens to this data after 30 days? Nobody thinks about life cycle of that particular data until and unless the bill becomes painful, right? So ILM basically answers all of the business questions. How quickly do I need this data? How often will I search on this data? How valuable is this data over time, right? At what point is the data no longer worth paying for? Like I don't need this data anymore. And this question is very important, that I don't need this data. Why am I storing it? So because observability data has this life cycle, ILM is the feature we all need to use for certain kind of life cycle, right? So let me show you what we are working with here. So ILM basically has certain tiering. Let me just do this. There are certain phases of our data that we are storing it. The first phase that I want to talk about is the hot phase. And you'll see all of the definition of all the phases are they're given in the UI itself, which is really nice. So I'll quickly just go over it once for everybody. If ILM is a new feature for them, I know people might know ILM already, so I'll just go it over very quickly. So first phase is our hot phase. This is where I think this is the necessary phase. This is where you store your data, which is like you want it to be searched really fast. You want it to be most frequently searched data right here. We want that in our hot tier. So our main data will be shifting to our hot tier at the very first moment. Basically, this is there for active troubleshooting. This is there for real-time search. This is there when we want dashboards to refresh. This is there for like everything that is very fast, very quick, right? This is fast SSD. They have higher CPU. They have more memory. They have faster indexing infrastructure at this particular tier as well. So this particular phase will keep our data nicely. You will see right now it is saying if you want to keep that data here forever, we don't want that. I'll say why. I'll explain why we usually move it to different phases. But let's go over to warm phases first. So as it says, we move data to warm tier right here. When you are still likely to search it, you can search it in the warm phase as well, but a little infrequently. We might not need to update it as much. We might not need to search for it as much. So we move it to warm tier. The benefit is, of course, cost part of it. These are a little less expensive. These are a little cheaper. So if for some reason we don't need our data to be in hot phase, we don't need it to be searched a lot of times, we move it to warm phase. Then there is also cold phase. We move this data move data to cold phase when we are searching it less often and don't need to update it. This is a key point here. If our data don't need any kind of updation, we can move it into the cold phase. And of course the searching will be a little slower as well. Of course the another benefit of it is that the cost saving, because search performance is a little optimized. Like we don't have that particular fast results now, but and we don't need to update it as well, so it is cheaper. Then comes the last phase, which is our frozen phase. This is for long term retention. Like one of my clients was keeping the data for 5 years, I guess. So firstly they were storing all the data in hot, which was definitely not acceptable. It was like killing their pocket a lot. So then they started moving into frozen phase. The idea here is you can store it in a very nice way. You can create searchable snapshots. I'll explain what that is. You can store it on certain repo that is outside your local clusters. So it will cost even like it will be even cheaper. So that is the frozen phase. Basically, when you just need to search for it, you don't have to write, you don't need updates, and you need very infrequent search as well. Then we move the data to frozen phase. I hope all the phases are certainly clear. Like we have divided it amongst 4 tiers based on how we want to search for the data. If we want to update the data, if we want fast results, we need hot phase. We move it to warm phase if we need certain kind of performance, like deep performance. So we can move it to warm phase. Still, we can update it, but infrequent updates, I would say. Then cold phase, you can't update it, but you can search for it. And then the frozen phase will just give you searches which are also infrequent. Now I'll quickly open the advanced settings for it and let you know what exactly is happening. The first thing that we need to like tackle right here is our rollover. So one simple explanation of rollover is we start writing into a new index. I guess rollover is the most important, I'm sorry, thing in the hot phase. Rollover simply means that instead of letting one index grow forever, the elastic will automatically starts writing into a new index once certain kind of thresholds are reached. I'll discuss what those thresholds are. Right now you can see we are using recommended defaults and it will say roll over the index in 30 days or if any of the primary shards reach 50 GBs. I'll quickly toggle this off. So you'll see we have this nice window where we can create our own thresholds. But the idea is simple. We don't want shards to become too large. If you don't know what shards are, I have actually tackled that in a separate webinar. You can definitely reach out to the old webinars as well. What are shards? What are indices? So basically, we don't want shards to be too large. Shards are, I'll quickly explain, very small unit which is storing our data, and we don't want them to be in a specific we basically want them under 50 GB. That is our thumb rule. You can see that right here. It is saying that as well because that affects our searching performance. That can create the recovery. That can slow the recovery. So we want it under certain thresholds. If for some reason we keep it under a single shard, we increase the data and we keep it forever under one index, it will definitely affect our cluster and our cluster management will become unstable over time. So for easy example, think of rollover like we start writing in a new notebook once our current notebook gets full. Basically simple as that. All right. So I'll quickly explain each of the thresholds as well. Maximum primary shard size. This is basically if one of the shard size reach a certain size, for example 50 GBs, Elastic will create a new index. Why 50 GB you might ask? It is basically a threshold thumb of rule. Basically the idea is from 10 GB to 50 GB for shards. This is considered as healthy operational balance because it is large enough for efficiency, but it is also small enough for recovery and search performance. So it is that balance between both. If I talk about maximum size, there is a limit for that as well. We keep 200 million docs per shard for that. So that is where that number can vary as well from 10 GB to basically per doc size can be different. So that is also there. We just calculated based on 10 GB and 50 GBs. So based on the document size, we can create a threshold as well. The other thing is age, and usually you will see all of the organization goes for age. We have the 50 GB mark as the upper threshold as well, but usually we roll over it like mainly through age as well. So right now I'll just create one policy. I'll use 7 days in hot, and then we'll be rolling it over to either the new phase, which is warm, or maybe I'll just quickly use the frozen phase. Okay. Now, if I go over the maximum age, it is nothing but If the shard size stays small, you may still want to may want a periodic rollover, right? For example, every 5 days, every 7 days. So that is where maximum age comes into play. It will basically simplify your retention policies. Let's move on. So basically, all of these are thresholds for rollover. If I talk about force merge quickly, that is nothing when the data basically becomes older and mostly maybe read only. This is where elastic can merge your smaller internal segments into a few larger segments on its own. So that is where few force merge come into play. You can enable that, you can provide a number of segments that you want to compress, but for the sake of simplicity I'll just toggle it off. We also have shrink here. This is basically to reduce a number of primary shards. I will deal this in another way as well. I have that demo that for certain kind of clients, they were basically using a large number of primary shards, which was basically causing oversharding. What that issue is, we will discuss that. So we have an option of shrink index for that to tackle that. But there is one more way we can do reindexing for that as well, which is I think is a little simpler, but we can use shrink index as well. All right. If I talk about searchable snapshots, basically, uh, how should I put it? So, searchable snapshot is like one of the biggest storage optimization feature in Elastic. And what it does is instead of storing full copies of data on the expensive node, you store the data inside a snapshot and it only retrieves it when you need it. When a certain call is made, you're searching for that data, it is stored somewhere else and it retrieves it when you only need it. Other than that, it is not costing you any storage value basically. So the idea is to save that storage cost. If replica is requirement is not necessary, you can save that here as well. You can save that infrastructure overhead. Same for downsample. Basically, the idea is downsample reduces your granularity over time. Suppose you have telemetry data, you want it to get reduced. You are using per second metrics. Now you can collect a 5 minute average of it over after 6 months. So you can do a downsampling here as well. If you want read only, you can do that as well. That is basically you create a certain index. You cannot not do any kind of updates on that, but you can just do searchables. So these kind of features are not particularly useful for hot phase, and you know why, because this phase is basically for searching. So I would say these are basically useful after we move to cold phase or warm phase, not particularly in hot phase. We also have index priority here. This is a really nice option of controlling an order. So basically we put an ILM, we attach that to a particular index template. I have explained templates before as well. You can definitely check that out. So if we want certain indices to be prioritized over the others, we can give a priority number here as well, and it will only prioritize a certain amount of indices. Those have this criteria basically. So these are certain options. I'll quickly introduce a warm phase as well. Now you'll see right here, it was giving me a maximum age for this, but in the warm phase, there is that move data into phase when. So if I put a 7 right here, it will move the data into this phase after 7 days. So I'll for now I'll put it 7 because I have put 7 on the maximum age as well. Certain similar advanced settings are here as well. The same meaning behind it. We have replicas here too. The idea is if I want to reduce down the replica from hot while moving from hot phase to warm phase, I can set the number of replica right here too. But let's not do that right now. Other than that, I'll quickly introduce the warm phase 2. We will put that, I would say, after 15 days. And let's put that in frozen. So, so in frozen, you'll mainly find a searchable snapshot. This is basically having a repo outside your local cluster. You can fetch that data from here as well. So right now for simplicity, I'll not be introducing the frozen phase, but you get the idea. Like after certain times, it will move to frozen phase. It will keep the data somewhere else. Whenever you are searching for it, it will fetch that. Okay. So now I'll just quickly click on this show request button. It is a nice feature of Elastic, and it will give you the exact API call of what it is doing. So we have the hot phase, we have rollover, we will keeping the max age as 7. We are keeping the max primary size as 50 GB. We have a priority set for it. The minimum age is 0 ms, like directly it will move to hot whenever the data comes. So this is what we need. Minimum age for warm is 7 days. So after these 7 days, up, remember here the minimum age is from the starting. So right here after 7 days it will move to warm phase, and from the beginning after 15 days it will move to cold. Okay, let's save this policy right here. So this is done, and this is how you basically work or create a ILM. So I just wanted to introduce that for the first time because we have never tackled ILM before. Now you have an idea of, okay, this is how retention policies work on Elastic. This is how I can attach that to a particular template, and this is how it will basically roll over certain indices. I can have my data being delete. Oh, let me go over the delete phase once as well. Let me click on edit. So you'll see right here, if in frozen phase, or let me remove frozen phase. I'll just, right now you'll see in the last phase it is giving me an option of keeping the data forever. And if for some reason, of course we don't want that, there are certain data that after some time we don't want that, right? So what we need to do is just click on the other delete button, and you'll see right here it will pop up another phase, which is our delete phase. Delete phase will take it all the day from the very beginning as well. So you will see after 15 days it will move to cold. Let's put after 30 days I don't want this data, so I'll just quickly put 30 days. Here we also have an option of deleting searchable snapshots. Right now, since we are not creating that, or maybe we are in the cold phase, so we can toggle this off, or we can toggle both of them on. Basically, if we want to delete the searchable snapshot, we can do that. That is the idea right here. Also, we have a thing called snapshot policy, which is right there with it is called SLM. Basically, it is there to keep this data however it is. Suppose some kind of mishappening happen and your cluster is down, so you can go back to a certain snapshot. That is why it is there. So to keep that, right now I'm not adding that policy, but that is a topic on its own. For future webinars I'll definitely discuss that. So now if I show you the request, we have a delete phase added to this as well. The action is after 30 days, it will delete this data. Another action is it will delete the searchable snapshot as well, which is right here creating right now, right? So let's save this policy right now. Let me to 30 days again. So I'll quickly show the request again. I'm sorry. Uh, so yeah, the minimum age is again 0 ms. We are moving it in 7 days for warm. After 15 days, we are moving it to cold. And after 30 days, we are deleting the data. If I click on save policy, it should be fine. It has created this ILM. Now the idea here is attach this ILM to any kind of template that is creating your indices. Suppose you have a certain index. For example, I was working with an healthcare client. They had their patient data under a patient index, right? They were using certain ILMs to take care of that. So what they were basically doing, create a template for that particular index, attach this ILM to that template, and you're good to go. Suppose you want that patient data, you are searching for that only for 7 days. So you will keep that in hot for 7 days. You want that data to be stored 6 months in basically right there. You don't want to search for it. So you'll directly move that to either cold phase or frozen phase. You're just searching for it. If there are updates expected, you might have to introduce a warm phase, and like that. You get the idea, right? So right here, I'll be moving back to my presentation. So the idea here is it will automate the data movement. You have different kind of storage. I'll just quickly show the architecture. Right here we have hot tier, you know that, warm tier, cold tier, and frozen tier. All right, just a sec. Okay. Right here, I would like to give you an example of one of the clients that I was working with. They were German client, and they were dealing with dialer logs. Basically, they were using Fluentd to move their logs from a platform to Elastic, and their environment basically was dealing with dialer logs, and they were using Hot for much longer than necessary. So when we received an actual search behavior, we discovered that most of the searches were happening in the first 5 days, right? So, and they were keeping it for no matter how long, like 6 months in Hot as well. So, when I created the ILM strategy for them, we shifted it like the Hot for 7 days. We introduced a warm phase because they needed a tier for midterm searches, and we directly moved it to cold retention. That single redesign of reducing a 6 month Hot tier to 7 days, that was a huge impact on cost. The Hot storage was really expensive storage. So because it has that compute, it has that memory, it has that SSD. So that was a huge change. So I always ask the team this question, like, when was the last time someone queried a 9 month old debug log, right? And usually everyone starts noticing, like, laughing. Nobody query a 9 month old debug log. So the question is whether we need it or not. That is the main question when it comes to retention. All right. So now we will give a quick session to Q&A. If you want, you can take over right here.
Yeah. So thank you so much, Savaga. That was really well put. We have one question. So Saurabh, he asked, so apart from ILM, we can also use ingest pipeline to limit what logs we are sending to, right there. So he asked whether, like, is there any other ways to control the costs besides ILM?
Yeah. Uh, there are a lot of ways to control your costs other than ILMs. As I said, I'll be discussing that in the future, like in this webinar only. There are certain cases where you are using mapping explosion that you can reduce down it to. There are certain cases where uh, cost reduction happens with certain kind of searchability. You are not searching for certain queries. There are right sizing ERU allocations as well, because for one client they were using the elastic calculator to calculate their ERUs, but they basically needed a 2 ERU per prod environment and they were using 5 ERUs. So you have to have certain kind of discussions around that to whether we are using whatever is needed or not. If I talk about licensing, we can have licensing as a major discussion as well when we are dealing with clients. So because certain clients don't have work of just platinum tier, and they usually use enterprise tier, and they are giving way more than what they need, right? We can also have certain kind of stack monitoring for this. Stack monitoring setup will basically align a lot of your cost related data, but majorly you will see that on the cloud elastic page, that these are my bills and these is what my ERU usage is, this is my usages. There are certain dashboards for it for you to monitor. Of course we need some kind of balancing there, some kind of marking there. So yeah, there are multiple ways to reduce cost, but we'll be tackling that in this session as well. Just a
I
second,
have
I
one
give
quick
me a moment.
question. Oh, go. Okay,
Mhm.
sorry. My bad. Go ahead.
No, go ahead. That is.
Okay. This kind of stems off the last question. So I'm just trying to figure out
Mhm.
something. How often do customers discover that observability costs, if I can speak correctly, they are like really ownership or governance problems rather than tooling problems? That's a big one in the industry I work in.
Could you explain that question? Like, what exactly are you looking for? What do you mean by like governance problem instead of actual problem? Like, uh,
Yeah, like the tooling problem stuff. So like, are the tools being used aligned
mhm.
with the ownership and governance problems that we're trying to figure out for observability costs?
Mhm.
That's basically it. It's kind of a weird
Okay.
question, but Yeah.
No. That is perfectly fine because that actually happens a lot. From what I can understand, your question is like suppose most of the organization assume this is a tool problem, right?
Hmm.
Maybe the platform is expensive. Maybe since Elastic is good for search, I think it could be that it is costing more. Maybe the ingestion volume is high. Anything can happen right here. So their first thought will be to assume that it is a platform problem. But I think in most of the cases, the issue is regarding the governance. You need to have certain kind of maturity to it, or you need to have multiple use cases in mind to see that okay, this is not a tool problem. Nobody revisited the retention policies after years. Mapping has evolved without standards. Like there are breaking changes, a lot of breaking changes in Elastic. They are improving their mappings day by day. So we have to question all the mappings that we have done before, like in certain frequencies. Every field becomes searchable by default. There are certain fields that we don't want to search, but nobody asks these kind of question. So I get your question. I know tools have certain problems, but majority of it is governance. Honestly, I will say that is one of the biggest mindset shift that organized grow through nowadays because observability platforms. Yeah, I hope I answered your question because that is a really good question, and I think majority of the cases that I have faced at the very end it is a governance problem.
Yeah.
uh yeah, one of the I think biggest changes that I'm seeing right now is dealing with governance instead of dealing with the actual tool. Of course there are like underneath the surface there are multiple things that are happening. There could be overshadowing, there could be uncontrollable indexing, there could be very noisy alerts, or we are storing either duplicate data or some kind of inconsistency, right? That can happen under the hood. But at the very end, how do we govern telemetry lifecycle? How do we govern certain kind of what compliances are we using? That is the major question that can impact like far more than just this tools question.
Cool. Thank you.
Right. So I guess so we have around probably 10 to 15 minutes left. So I think we can continue and then we can cover more questions toward the end.
All right, perfect.
Let's do that.
Let me share my screen again. Okay, so I'll quickly go over the real world examples because I think that will be the most impactful for what we need to uh, face right here. Just a second, I'll try to share my screen again.
Sure.
All right. So one of the use cases that I have faced for one of the most biggest client that I have worked with, and it was really around overshadowing. So I worked with overshadowing in the healthcare environment. We have identified a certain index that only had like 13 14 gigs of data, and technically they were unnecessarily using 6 shards for it. Now definitely 13 GB don't need 6 shard. We know the thumb rule by now that 50 GB per shard, right? So they were using 3 primary and 3 replica for it. No, not 3 replica, I guess 2 replica for it, and they were creating 6 shards, right? So while the platform was functioning very nicely, very correctly at the very beginning, but this design was unnecessarily creating a lot of shards for those index, and I know over time this will affect that. So what I did, one way to deal with it is just reduce the number of shards. Right now I'll show that quickly how we can do that. So I have this one, I'll go from the beginning. I'm creating one of the index right here. The name is demo patient index v1. The idea is in the settings I'll be using number of shards as 6 and the number of replicas as 1. What this will do is create 6 shards for primary, and there will be 1 replica for that as well. And right here, don't need to like focus on this much. This is just the mapping of the data that I'll be bulking next to it. So let me just run that. Okay, so here we have created that index. I'll quickly show you the bulking API as well. We have put certain kind of docs in it. The idea is certain example docs right here. I can quickly show whether that index is created or not right here. This API basically will tell you how many primaries and how many replicas we have. So right here you can see under primary we have 6 primaries and under replica we have one replica. So basically what it will do is it will create all the replicas of this 6 primary. So in total we'll have 12 shards. Now we don't want 12 shards for just these amount of docs, right? So one idea usually that we do when we are dealing with it, there are two ways to handle it. Right now we have another API that can break down the shards, but most of the cases we'll just do a reindexing. So what the idea is, we'll create a new index with less number of shards. We'll create like number shards being one, number of replica being one. We'll provide, if needed, we can provide the mapping changes here as well. I have that example too of doing a mapping change. And I have taken care of this exact use case for that client. So we can do that, but right now I'm just doing the number of shards. So let me create this index. This second v2 index is created now, demo patient index v2. So we have two index now. I hope that you are getting a picture of it. This one has number of shards as 6. This one now has number of shards as 1. Now what we'll simply do is just this reindex API. This is a very powerful API. If you perform any kind of changes into the index, you can do a reindex for that, whether it be mapping changes, whether it be setting changes. So right here I'll just reindex. The idea is to provide a source, which is our v1 source index, provide a destination, which is our v2 index, and it will reindex it in the second version. Now it is copying all the documents. All the documents are also present in v1. That is a key point to remember. So I would say deleting the first index would be a good practice here, after you have validated the number of docs in both of the index, of course. So I'll quickly do a v2 in the second index. You can see right here we have one primary and one replica, and we have all the docs nicely. Now let's delete this index and we are good to go. So this is a small demo to give you an example of how you can change certain things very easily in Elastic. If you need certain kind of mapping changes, if you need certain kind of setting changes, you can do that. Another thing is I'll quickly show a mapping change here as well. For example, for the same client, they were using a lot of nested fields and they were not even searching for that. So what I did was I have optimized their mapping by redesigning it. We need to have a whole sheet of all the fields, whether we are using it or not. These processes could be time taking, but believe me, over time, it will save a lot of cost when we are dealing with large scale. So all the fields, we have to see whether we are searching for that, whether there is the right data type for it. Because right now, see, I have created a mapping for this particular index. This is a log v1 index. What we are doing is we are keeping certain fields under text, certain fields under keyword, another text, and we are basically doing a nested field. What nested field does is you can create more fields. This is basically an array, and you can create certain fields under that too. But in certain cases, this is no longer needed. You don't need a nested field. There are better options, like you can create an object for that. You can have, there is another option of flattened field, which is a lot cheaper when you are not basically using for that. So for this particular client as well, we optimized mappings by converting the nested field to flattened fields. So I'll quickly show you that. Let me, now the same idea right here. We created two of the index. Let me put this. We have created the first index. We have put a doc into that. We can search for that doc. It is right here. Okay, so we are searching for v2. Let me just do that for v1. This doc is right here. When we put another index with new mappings, we can simply just reindex it. Now, right here, we also have an option of rolling it over, but that usually works with the data streams. It is a simple API call as well. You just need to post it. You just need to provide the data stream name right here. And you just need to, I guess, let me put the index name for now so that I can show you what it looks like. Demo v1. And yes, you just need to run underscore rollover. This will not work right now because I think it is not, yeah, this is a concrete index. It only works on data streams or an alias. So I hope the idea is clear. Certain kind of mapping decisions can be taken to reduce the cost as well. Uh, Other than that, there are examples of cost reductions that I have done with ILMs, with shardings, with mappings. And one more example would be to do architecture changes. That is one of the major example. If you are using a lot of gigs of data, you are scaling it a lot and you don't need that, you definitely need to scale it down, right? That is one of the major issues that most of the organization faced. I think we all know that we need to have certain kind of cap on the actual scale of the cluster. All right, so those were some of the examples that I have faced with that are small changes, but that can affect in the long run a lot. All right, we are open to the questions if anybody has a question.
Right. I have one follow-up question. So when we talks about what you mentioned about the index lifecycle policy in the beginning, so if you
Mhm.
could tell us like what are the key business metrics a company should look at when deciding the retention timelines, like from the business
Okay.
business perspective.
Mhm. Mhm, mhm. Yeah, that is one of the most important question, I guess, when we are talking about ILM. I would say the first metric is search behavior. You need to see how far back do the engineers realistically search during incidents. Like what kind of telemetry data is actively being searched. That is, I guess, one of the main uh, key metric. These decisions are usually business driven instead of purely technical, because at the end of the day the business is using that data, so we need to know what exactly they are using it for, how long they need it, how rarely they need it. So I would say first is search behavior. For example, in certain environments you'll find that 80 to 90% of operational search are done within certain amount of days, and we don't want the data after that, right? So we move that into certain other tiers. Another major factor is, of course, as it was mentioned, compliance or audit requirements. Whether in healthcare organization we need longer audit retention, whether we need security log retention, whether we need legal hold capabilities, those kind of questions also decide how we should treat ILM, how we should decide what is the metric for ILM, what is the final decision, right? So compliance is there, of course. I would say another factor is business criticality, whether certain data is more important, whether certain data needs to be stored longer, it needs longer attention. Of course, that is there too. So yeah, those are some key metrics that a particular organization needs
Hmm.
to keep in mind when we're discussing retention.
Cool. All right. Another one thing is that the main topic for today is about cost, right? Like reducing the
Mhm.
observability cost. So you had to pick probably, let's say, three things that like people, someone that working on observability, the ILM platform that you should consider if they want to reduce the cost. Like just in short, maybe
So
three
do you mean
things.
what are the three options that they need to
Yeah,
consider when they are
exactly.
reducing the
Yes.
cost?
Yes. Yes. Yes.
Okay, so I would say ILM should be the first one,
Mm.
and yeah, that is like the highest priority right here.
Okay. So that's
And
cover everything.
yeah, like the major part of it is usually islands, because that is where the data, that is where the main cost is coming from, that is where the data is written. The other thing is, I will say, scalability. As I mentioned, a lot of organization don't need a lot of sizing, they just did it for certain use cases. Of course, yeah, this right here, auto scaling comes into play.
Mm.
So that is a good option. We need to auto scale it based on our need. So right here you can save a lot of money. Other
Mm.
than that, small decisions like, as I mentioned, mapping, small decisions like how we are searching that data, that can, if we are talking about large scales, that can definitely affect your cost.
Cool. Okay,
Mhm.
I think that's all the question from my end. Any other question, everyone? Thank you for staying to the end. Hit follow us. Da, da,
No, I
da.
just want to say thank you for all of this. This was really good information. Um, I'm extremely
Cool.
impressed by
Thank
how this.
you. Thank you
Thank
for
you, thank you.
joining. All right.
Yeah.
So before summing up,
Yeah, I have
yeah.
one question.
Oh yes,
It's,
please.
Mhm.
so in upcoming days, do we have some AIOps related demo. I mean to say, like in Elastic, we integrate some AI, and this will probably read the logs and give the remediation. So, like in that way, I just want to know.
I think the next webinar is AI related. So
Yeah.
that's why I
Oh,
was going
that is
to.
great.
I pretty much spoiled everything. So yes, so we're gonna have a next upcoming webinars next month for about the AI assistant with Elastic Agent Builder. So it will be me with other engineers. He's participating there. So please stay tuned. Now the registration is opened on LinkedIn. All right. Yeah. If you go to our Hyperflex LinkedIn page, you would find the event is up and running. So please go in and register. It's really interesting sessions. So really looking forward to meet everyone. All right. So if there are no other follow-up questions, so thank you so much for joining our session today. And again, if you are family face, you already know we host events like this every month. Yeah, and please stay tuned for the upcoming ones on our social medias, LinkedIn's, and Instagram, YouTube, Mediums. Also, this session is recorded, so we're gonna have the on-demand version posted on our social medias probably in the upcoming week. So stay tuned for that, and thank you so much for joining, everyone.